YouTube channel. So I'm here with another challenge problem on integrals. So guys, this time this is of an exponential function e to the power 2x plus ln of x. So guys, as you can see from this problem that there is no like a direct or straightforward method or technique to actually evaluate this integral. So we have to come up with something different, something unique here, and that is what qualifies this as a challenge problem. Okay, so what I'm going to do here is, guys, looking at this this piece right here, this exponential function, what I can see here is that there is some sort of connection between the exponential function e as well as the log functions, and that is something that we are supposed to know, and the relationship is that they are the inverses of each other, so they basically just cross out each other. So guys, keeping that in mind, I'm going to try to simplify this piece. So simplifying here would mean what I'm going to do is I'm going to rewrite this as a product of two quantities, and using the basic rules of the exponents, we can rewrite this as e to the power 2x and then times e to the power ln of x. And guys, keep in mind that we are doing all this because there's no direct way or any other method for us to actually evaluate the integral of this function directly, right? So that's why we are trying to figure out some other ways, which in this case would start with just by rewriting this function as a product of two functions. Again, we know the basic rules of exponents. When we have the same bases, we just simply add the exponents. So this is exactly same as that. Now from here, things are going to get more simpler, and that is the reason why we kind of started with this. And again, we didn't had any other choice, so we had to kind of try to simplify this piece. And this is like one of the ways to simplify this. So this is same as integral of e to the power 2x. I cannot do really much with this right now, but guys, this guy right here, we know the exponential and the log function, they are the reciprocals of each other. What does that mean in this case? This means that the e and the ln kind of would cross out, right? They will just negate each other, and I will be left with just only an x. So guys, we were able to, just by rewriting this as a product and then realizing that the exponential and the log are the reciprocals, so they just kind of like cancel each other out, we're going to be left with just an x. Now this right here is a product of an exponential function and a simple algebraic function. In fact, this is just a simple linear function. So guys, from here we should know that the integration by parts method would be the best method to actually evaluate this integral. And from integration by parts, let me just remind you the first step for that. The first step is to actually identify my f function and the g function. The way I like to do it, guys, I have my like an own formula kind of, which we usually don't find more often in the textbooks. So what I do is I identify the f and g, and then I use the integration by parts formula. And in this case, obviously, we are going to use this as f and this as g, because keep in mind we are still following this ILATE technique, where algebraic function takes the precedence over the exponential function. So algebraic function is x, so I'm going to use that as f, and the other one, the exponential function, as my function g. Here, guys, I'm going to write the general form for integration by parts, and then we are going to use that formula to actually evaluate the integral for this. So guys, the formula that I like to use, and which I have already uploaded like the whole proof and derivation of that formula on my, again, one of the videos on my YouTube channel. So feel free to actually check that out, or if you are using your own technique, you can also use your own technique. Guys, this is a f. This is f, sorry, so I think I need a different marker here. So this is just f times integral of g dx minus, so guys, I'm writing the general form, and then I will use it and will apply it on this particular thing. So minus integral of f prime times integral of g dx, and then we have another dx. Right, this is what I like to use. The textbooks usually have a different form in terms of u and v, which is basically not anything different than this, but it's slightly like a different version of this. Okay, so guys, it's up to you which one you want to use. So I think I need a different marker here, so I'm going to use this one right here and see what we get. F is my x, so I just have to write that x times the integral of g dx. So I'll write e to the power 2x. Guys, I'm still trying to write all my steps. Then what do I have? I have minus integral of f prime. Let us do f prime right here. The derivative of x is just 1 times integral of e to the 2x dx, and I still have a dx outside, right? Simplifying further, this is just simply going to be x times e to the power 2x divided by just 2, because we know the integral of an exponential function is the exponential function itself, but since there's a 2 with the x, we have to divide by that coefficient of x, or you can also think of that as dividing by the derivative of this exponent, or derivative of the inner. That takes care of this piece. Then this is minus, and let us see what we have here. We have the integral. 1 is not going to change anything. We just have to evaluate the integral of this, which is the same thing, e to the power 2x, what we had here, divided by 2, and then there's this dx, right? I think we just have to do probably one more step and we'll be done. So this is x e to the power 2x over 2, right? That is already being done. And here we can already take out that 1/2 outside. I just have to find the integral of e to the power 2x one more time, which is again e to the power 2x divided by 2, and then there's a plus c. Guys, I can already simplify this 2 and 2. 2 times 2 is just 4. So I'm just going to write it right here. So here I have the integral of this function. But guys, keep in mind, again, we would not be able to figure this out using any other techniques that we have learned so far, none of the direct methods as well. So one has to just look at this carefully for a second and then figure out like, hey, if I break it down into product of 2, which we can using the basic rules of the exponents, and then also keeping in mind the fact that the exponential and the log function are the inverses of each other. So they will cross out, they will negate each other out, they will cross each other out. So I'll be left with just the linear function or an algebraic function x, okay? So from here, we are able to use the integration by parts formula, and we're able to actually evaluate the integral. So guys, this is another challenge problem on evaluating integrals. I will see you next time with another video. Till then, take care.